Okay, hello everyone. I'm Paarth.
Hi, I'm Shriya, and today we're going to be revising some IB physics topics.
Okay, I'm gonna share the screen. Okay, we're just gonna do a few practice problems and then um, go from there. So we're gonna start with number 5. So it says that um, Felicia, the ballet dancer, has a mass of 45 kilograms. What is Felicia's weight on Earth? And what's her mass on Jupiter? And then what's her weight on Jupiter? So we know that the formula for weight on Earth is weight equals mass times the gravitational force. So for A, it's just going to be 45 kilograms times 10 meters per second squared. So for A, your answer is just 450 newtons. And a reminder that weight itself is a force. We just write units um, for the units basically. And then for the second one, for C, what is Felicia's weight on Jupiter? You would use the same formula. So you could use W equals mg as well, and then it would be 45 kilograms times 25 meters per second squared, which equals what is that total? 1125 newtons. But the thing is, you want to keep it at 3 sig figs, so it would be 1125 newtons. Okay, the next question that we can do is let's do some of the conceptual questions. So if an elephant were chasing you, its enormous mass would be very threatening. But if you zigzagged, the elephant's mass would be to your advantage. Why? So this correlates with Newton's first law of motion, which deals with inertia. And it basically says that, right, if an object is at rest, it will tend to stay at rest unless acted upon an external net force. Same with if it were in motion. So that means that the more mass something has, the more inertia it has, which means that the more it takes for it to come to a stop, the more resistance it requires in order for it to come to a stop or change its acceleration. So in this case, since the elephant has such a large mass, it would not be allowed to change its acceleration very easily. And then we can do this. Let's do 12. Okay. If a woman weighs 500 newtons on Earth, what would she weigh on Jupiter where the acceleration of gravity is 26 meters per second? Oh, well, we just did something similar to that. So I will do, okay, let's do number 11. When a 1000 Newton barrel is sinking through the water at a constant speed, what is the upward force of the water on the barrel? So the biggest thing to notice here is the word constant speed. If something is at constant speed, that means that the acceleration is, one second, that means that the acceleration is 0. So this means that since the acceleration is 0, that the forces would have to balance out. And so we could even draw this out. This is the barrel. And let's say it's sinking because of gravity. And it's sinking at 1000 newtons. And the reason that I'm doing it downwards is because when you're drawing weight as a force, it's always downwards. So if it's moving at a constant speed, this means that I believe this is called a normal force, would also be 1000 newtons. And the reason for that is that it's at a constant speed, which means that your net force is 0. If your net force is 0, that means you're moving at constant velocity and 0 acceleration. Also, just a quick thing that the normal force is perpendicular to the object itself. So it looks a bit confusing. It doesn't look like it's perpendicular, but if you look at the surface of the object, it is perpendicular. Okay, let's go to the next question. Um, let's do number 3. So the following forces act on an object 10 newtons north. So the best advice that I would have for this type of problem is to draw it. So I'm going 10 newtons north and then 50 newtons south and 40 newtons west. So now I have to connect these vectors together. So I would start from the origin and I would go 10 newtons north, 50 newtons south, and 40 newtons west. So what I see here is that I have two vectors that are going in the same direction. So I can find the net force. So this is 50, this is 40, and this is also 40, right? Sorry, no, that's not 40. This is 10, right? And then this is 40, which means that if you check your net force of this, you would get that the vector is actually 40 newtons south, right? Because we're calculating the net force. So here it's 40. And so here we're dealing with two different vectors. So so what you need to do is here, you need to add the two vectors. So here I have the 40 newtons that are south, and then I have the 40 newtons that are west. So in order to add these two vectors, I have to use the head to tail method. And so the way that I drew it was this way. And so what you would do is, since this is 40 and this is 40, based on just simple vector rules, I'll do it over here. You would do the square root of 40 squared plus 40 squared. And so that would be approximately like 56.56 newtons. But since we're dealing with, we are dealing with two sig figs here. So I would go with 60 newtons, but to be more, I guess, accurate, you could do 57 newtons. Okay. Shriya, do you want to do number 4?
Yeah, I could do number 4. So a 200 kg bear grasps a vertical tree and slides down to constant velocity, and they're asking the friction force between the tree and the bear. So for this, you have to use this formula. So friction force, so that's force of friction, is equal to the coefficient of kinetic friction, which is like mu, times the net force. So
The normal force, yeah.
yeah. So the first step is to figure out what you have. So Miss Raja always asks us to draw a free body diagram when we start. So I'm gonna attempt to do that with what we've been given. So let's say this is the bear, and we know, and I know it's holding a tree, but this can just be a very simple free body diagram, and or actually it'd be like this. This is the tree. So it's kind of different because it's sliding vertically down. So this would be your F normal, which is your weight, because the bear is exerting that weight on the tree, and also the tree is exerting that weight back up. So that would be 200 kg and then it's sliding down, so this is its constant velocity, and then there's a friction force as well. So that's just a very simple free body diagram. So what we can do is we know that its acceleration is 0 because it's sliding down at a constant velocity. So the net force is 0 according to the second law of Newton. And according to this free body diagram, there are two forces that are on the bear. One is its weight, which is pulling it, I know it kind of looks weird here, but it's pulling it kind of downward, and then the frictional force is pushing it upward. So we have to find the net force between the two forces, and then from there we can find the frictional force. So so the frictional force is essentially just or sorry, the net force, not frictional force. Erase this. It's not erasing, but I'll just write it on the side again. So the net force is basically the weight minus the friction force, which will end up being 0. And then you know that if we kind of solve it, we know that the frictional force is basically just your mass times your gravity, because we're using this previous equation we have here to figure out that in this case frictional force equals the weight of the bear. So we could just say frictional force is equal to mass times gravity. So the mass over here is 200 times, and gravity is roughly 9.81. And let me put in my calculator and make sure.
Yeah, for the purpose of this class, you can just do 10. So 200 times 10,
yeah,
2,000.
Yeah, but the actual answer would be 1,916 newtons.
Yeah.
Which is the frictional force.
Okay. Okay, let's look at number 9. So suppose that you exert 400 newtons horizontally on a 50 kg crate on a factory floor when friction between the crate and the floor is 200 newtons. What is the acceleration of the crate? So I'm exerting my force 400 newtons horizontally. Let's say I'm exerting it 400 newtons to the right. Based on our knowledge of friction, we know that friction acts in the opposite way. So that means that friction is acting this way, and this is 200 newtons. So this means that your F net is 200 newtons. So now that I have the F net and I'm asked to find acceleration, if you look at the information you're given, you're already given the mass. So F net equals mass times acceleration. So I have 200 newtons equals 50 kg times A. I'm going to divide both sides times A to find my acceleration, and you get your acceleration as 4.0 meters per second squared. In this case, you can put 4 though, because we have one sig fig at each one of these answers. So it would be 4. So number 11 was a really challenging problem, in my opinion. So I'm just going to go through it to see how we would solve it. It involves kinematics as well. It's like a connection of what we learned last unit along with this as well. So 1 second. Sorry about that. Okay, so annotate. So it says a 30 gram arrow is shot by William Tell through an 8 centimeter thick apple sitting on top of his son's head. If the arrow enters the apple at 30 meters per second and emerges at 25 meters per second in the same direction, with what force has the apple resisted the arrow? This is so many numbers and so many different things I have to deal with. But the first thing that I would do is set up simple conversions. So I'm going to convert 30 grams to kilograms, because when you're dealing with motion, we're always using kilograms. So it's going to be 1,000 grams in 1 kilogram. So that means that I have, I believe, 0.03 kg, right? And then I also need to convert 8 centimeters into meters. So 8.0 centimeters times 100 centimeters in 1 meter. So my centimeters cancel out, and I get 0.08 meters. So these units are very essential to these question because if you don't use these units, you're going to get the question wrong. So make sure that your units are always how you want them to be. So the next thing that I'm going to do is that I already know I know the velocity of these things. So what does that mean I can do? That means that I can use the velocity, the initial velocity and the final velocity to find the acceleration. So I'm going to do it on this top space here because it doesn't really cater to the problem. So I have that u equals 30 meters per second, right? V equals 25 meters per second. X equals 0.08 meters, right? And we're trying to find A. I don't have any other information. Using my knowledge on kinematics that we learned last quarter, this means that I have to, by default, use V squared equals U squared plus 2AX. So this means that we're going to plug in 25 squared equals 30 squared plus 2a times x, which is 0.808. So 25 squared minus 30 squared, yeah, that's right. 25 squared minus 30 squared, that's negative 275 equals negative 0.16a. Negative 275 divided by negative 0.16. So then, sorry, I don't know where I got negative 0.16 from. So you get 0.16a. So using this, I've solved for my acceleration. My acceleration is negative 1718.75 meters per second squared. Wait, but I'm not done yet. I have my acceleration and I'm asked to find the force, which means I'm not done yet. But I'm very close to being done because I have the mass and I also have the acceleration. So using our F net equals ma formula, I'm going to plug everything in that I have. So I'm trying to find my F net and I have 0.03 kilograms times my 1,718.75 acceleration. And that gives 1718.75 times 0.03. 1718.75 times 0.03. That's 51.6. And a reminder that the acceleration is negative here when we calculated it. So that means your final answer is going to be negative 51.6 newtons. This is a very multifaceted problem, so just be careful. And reminder that you are going to keep things at 3 sig figs here because we're given 3 sig figs. Okay, we're just going to do a few more problems from homework 2. Let's do number 13 because it deals with a free body diagram. So while redecorating her apartment, Katie slowly pushes an 82 kilogram china cabinet across the wooden dining room floor, which resists the need through motion with the force of friction of 320 newtons. What is the coefficient of sliding friction between the china cabinet and the floor? So it's asking for the coefficient here. And so honestly, this is just simple application. So F friction equals mu times your normal force. So let's draw a free body diagram. So 82 kilogram china cabinet. I'm not going to make this too fancy, but this is my china cabinet. And it resists the motion with the force of friction of 320 newtons. So let's say Kitty is pushing it to the right. That means your friction force is going to act to the left. And then it's asking for the coefficient of sliding friction. And the way that you would do this is that since you're given the mass, you can actually find the gravitational, you can find the weight, and that would be Once you find the weight, once you find this vector right here, this means that you can assume that you can also find the normal weight right here. So let's use the information that we have. We know that weight equals mass times gravity. So this would be 82 kilograms times 10 meters per second squared. My weight is 820 newtons. So I know that this vector right here is 820 newtons, and I know that the normal force as well is going to be 820 newtons. So now that I have my normal force, and now that I have my friction force, it's simply plugging in. My friction force is 320 newtons. I'm trying to find mu, the coefficient, and I know that my normal force is 820 newtons. I'm going to divide both sides by 820 to get my friction force, and you would get that your coefficient is 0.39. So this is simply plugging in, and drawing a free body diagram really helps. Let's look at another one that's involves a friction force and also a free body diagram. Okay, so this is a good one. Howard, the soda jerk at B's dinner, slides a 0.6 kilogram root beer from the end of the counter to a thirsty customer. A force of friction of 1.2 newtons brings the drink to a stop right in front of the customer. A, what is the coefficient? And B, if the glass encounters a sticky path on the counter, will the spot have a higher or lower coefficient of friction? So the second one is more of a theoretical aspect. So I know that my weight is 0.6 kilograms. So I'm going to draw the free body diagram just from here. So I have this, and then I also have these forces. So I know that my friction force is 1.2 newtons. So it looks like he's sliding it to the left. So I'm just going to do it to the right here. You can perceive it however you want it to be. And then I'm also going to look at weight equals mg. So the weight equals 0.60 kilograms times 10 meters per second squared, which means that my weight force is 6 newtons. So this force is your weight. This is your mg force, the downward one. And then this normal force is also going to be 6 newtons mg. So while it does look like it's a complicated question, essentially it's just plugging in everything back into the equation. So then you're left with plugging everything back in. So we know that our normal force is 6 newtons, and I know that my friction force is 1.2 newtons, which means I can use the formula F friction equals mu times Fn. So if my friction force is 1.2 N, and I'm trying to find mu, and this is 6.0, I divide both sides by 6, and mu gives me 0.20. That should be your answer. And then it also asks a second question. If the glass encounters a sticky path on the counter, will the spot have a higher or lower coefficient of friction? So the way I like to think about this is, let's say you're walking through glue, a very rare circumstance, but even your fingers dealing with glue, it's really difficult for you to get rid of that glue, right? It's because the force of, or like, okay, let's just put this another way. You're walking on glue, and it's extremely difficult to resist the force of friction because it's really hard to actually pick up your legs and move right across the glue. Whereas on the other hand, you're on an ice skating rink and you have a puck and you slide it. It's slippery, right? It's not going to have as much friction. A slippery force would have lower friction than a sticky force. Does that analogy make sense? Like glue versus puck? Yeah. Okay, it says Skelly the child skater is propelled by rocket power. Skelly and the rocket together have a mass of 25 kilograms. When the thrusting force is 100 newtons, and friction is 20 newtons, what will be Skelly's acceleration and how far will he go in 5 seconds if he starts from rest? So here we're dealing with not only motion, we're also dealing with kinematics. So if I know, so thrust is a horizontal force, I believe. So if your thrust is this way, if this is your 100 newtons in thrust, and then this is your 20 newtons of friction, right? That means that your net force would be 80 newtons. Is that right? Yeah, I think that's right. F net equals
Yeah, that's right.
80 newtons, right? And then from there, we have information on the mass. And I already know the Earth's gravitational pull. So I'm just going to do weight equals mg. So weight equals 25 kilograms times 100, sorry, sorry. I'm trying to find the acceleration. Sorry. Okay, so yes, it's correct that you're dealing with weight, but at the same time, it's asking for acceleration horizontally, so it's not dealing with downwards weight, I guess. So actually, we're gonna have to use F net equals ma, right? So I know that my net force is 80 newtons, and I know that the mass is 25 kilograms, right? So just ignore what I said about weight equals mg. So then divide 25 by 80, and you have that your acceleration is 3.2 meters per second squared. Okay, so it looks like I have my acceleration, and it looks like I have time. Well, what else do I know here? How far will he go? So I'm asking for x. So let me move this cursor a bit. Oh wait, let me just, okay. So if it's asking for x, let me write down the components that I have. So first of all, it says that you're propelled by rocket power. That implies that your initial velocity is 0, right? If you're propelled by something, so u equals 0 meters per second. Acceleration is 3.2 meters per second squared. T is 5 seconds. I'm trying to find x. Well, I know that I can use x equals ut plus 1/2 at squared, right? So I'm going to plug it into that equation, and you would get 1/2 time. Well, you know that u is 0. So I'm just going to completely disregard ut. This is 0. 1/2 times 3.2 times 5 squared. 25 times 3.2 times 1/2 is going to give you 40 meters. So this is another one of combining forces and kinematics. Okay, the last one that I'm gonna do for today is 25. It says two forces are applied to, this is applying information that we learned with vectors, like how to add vectors and things like that. So two forces are applied to a 5-kilogram object. One is to the 6 newtons to the north, and the other is 8 newtons to the west. The magnitude of the acceleration of the object is what? So I'm going to start from the origin, and I'm going to go 6 newtons to the north. Oh, that's a terrible drawing. Let me redo that. So I'm starting for the origin, and I go 6 newtons north, and then I also go 8 newtons west. So this is 8 newtons and this is 6 newtons. So based on the information that I'm given, I have to add the two vectors. So if I'm adding the two vectors, it's going to be this. So using your Pythagorean triples knowledge, this would give you a 3, 4, 5 combination. So this is going to be a 10 newtons. If you don't remember that, that's okay. Just do the square root of 6 squared plus 8 squared, which is the square root of 100, which is 10 newtons. So now that I have my force, now I need to find what my acceleration is. I also have my mass. So it's going to be 10 newtons equals 5 kilograms times the acceleration. I'm going to divide both sides by 5, and my acceleration is 2 meters per second squared. Okay, so we covered a good amount of questions today. And really quickly, I'm just gonna screen share a whiteboard and show the three different laws of motion and how we should write them, rather than like with a theoretical understanding rather than just surface level of what we learned before. So Newton's first law of motion deals with inertia, right? Wait, can you see that on my screen, Shriya?
Yeah.
Okay, so Newton's first law would be that an object that is at rest will tend to stay at rest unless acted upon an external net force. And then you could say the same thing for an object that's in motion. If you want to put this in a fancier way, you could say that an object will stay at constant velocity unless acted upon by an external force. So that's a really fancy way to put it. So Newton's second law of motion, it's more than just force equals mass times acceleration. So this one, you would kind of have to set it up, like just interpret the linear function itself. So the acceleration of an object is, I guess you could say, like created by the net force, in which it is directly proportional to the net force of the object and inversely proportional to the mass of the object. So how can we interpret this? This means that if you have more mass, that you're going to have lesser acceleration. And if you have less mass, you're going to have greater acceleration. And then for Newton's third law of motion, Maytha, we already finished like 10 practice problems, but I'll upload it to YouTube and you can watch it whenever you want. But we're just going over the law of motion before the end of the meeting. So if object A exerts any sort of force on object B will produce a reaction that exerts a force that is equal in magnitude and opposite in direction. So these are your three laws of motion that are really important for you to understand more than just the definitions, understand it conceptually too. Hope this session helped, and thank you for watching.